One. Hi. Hello. Oh, good morning. Is it sound and volume and everything is okay? Yeah, cool. Great. So, hello. My name is Oleg, and I'm here from ZeroTurnaround company. The talk's name is Do You Really Get Class Loaders? And this is a really established ZeroTurnaround's classic talk. So it has been given a number of times. So most probably, at least some of you have seen some flavor of that. So how many people know what this talk will be about? So, no. Okay, how many people have seen anything with the name Do You Really Get Class Loaders previously? Okay, quite a lot. So you will judge me, compare me to my predecessors. Still, so I'm a product engineer at ZeroTurnaround. So I'm working on a product called Rebel mostly, which is a release automation tool. So we integrate with different application servers and do lots of low-level magic. So there I get my experience with class loaders and stuff. So, but the most important piece of background that we have at ZeroTurnaround, our experience with class loaders, comes from JRebel. And that is another product that we have, and we will talk about that a bit later at the end of the presentation. But what it does essentially, it hooks into the JVM class loading scheme at the moment of the startup, and then it does some transformation with classes. So naturally, all problems that can occur with different class loaders, implementations, and different hierarchies, all of them we have seen. So this talk will be based on problems that usually occur when you do something related to class loaders, and we will see a couple of examples of those and see how you can troubleshoot them and which tools are available for you and what to do if you see a weird exception with a class loader word in it. So this would be what we do. So we'll cover the basics of class loading, what it is, how it was intended to happen in the Java and in JVM world. Then we'll go to the practice session and see some code. And then we'll talk about a bit about the class loader leaking and why you often see stuff like permgen, exceeded exceptions out of memories because your class loaders leak somehow. And then we talk about modern solutions for all kinds of problems. So back to basic. A class loader usually denotes either a concept or a concrete implementation and concrete thing in Java world. So the concept is very simple, but we start with implementation first. So it's a Java class, nothing more. It's a usual class with a surprisingly low number of public methods and methods that you actually want to use somehow. So the most important one is the top one, load class. It takes a parameter name, and that is a fully qualified name of a class that you want to load. And internally, it does something and produces back an instance of a class that you just requested. So this is how the whole JVM actually converts the bytes that reside somewhere in a jar file. It converts into an instance of the class that you can instantiate and create the object of. The second method is define class, which is also kind of important. So if you just have a definition of a class, you read the file and you have the bytes that describe this class, you can just define it directly without looking up in any class path resources. Next, we have two methods that deal with resources itself. So basically, as you know, everything are just like sequences of bytes. So when you have some idea where a class could be, or you want to find an exact bytecode representation of the class, you can just ask by name, and class loader will return an URL to where it loaded this class from, or multiple URLs in an enumeration. And finally, the last one, the most important, for this talk will be a get parent. So all class loaders in JVM form a hierarchy. Every class loader owns a parent, except obviously the root one, the bootstrap class loader, which system instantiates and loads runtime classes. And this hierarchy scheme will be really important because it's really useful. So, but we will talk about that a bit later. So a simple example, obviously incredibly simple Java code. But what happens here, so we have an instance of class A, and when we call the method do something, it instantiates an instance of class B and does something else. So at the first sight, nothing curious could happen in this code, right? So it's that simple, but apparently it's not exactly that. So when we actually execute that constructor on the B, before we can obtain the instance of B, we have to, JVM has obtained the instance of the class that creates B. And it figures out in a way that class B, in this example, will be loaded by the same class loader that class A was loaded from. So, and this is where hierarchy comes into role. You have a class loader on some level, and it loads some classes. And when any of those classes will require additional ones, they'll be also loaded at the same level. So you can already feel that something shady will happen if we have different levels and different classes loads will be loaded into different class loaders. So, and we'll consider that also a bit later on the examples. But when you create a new object of some class, actually that class gets loaded for the first time. After that, obviously, the class is already loaded, so it wouldn't be. So the intentions to create this scheme of class loading was to provide your programs a mechanism to locate additional resources that you would be able to pull up into the JVM and use them. So not only, So the runtime classes are loaded by the bootstrap class loader, and they're always available. And your application is mostly resides in the class path, and it's also usually available. But there are a couple of situations when you don't have the bytecode for the application that you want to run. For example, the notorious applets or something. So your environment sits at one machine, and you probably want to load something from a different remote location on the network. You will have to create a specific class loader that will be able to obtain bytes through the network call, and then you load that. So it's a great and really flexible feature to enhance the distribution and ability of Java applications to obtain pieces of program that they want to execute. And obviously this hierarchy is really useful too, because you don't want to initiate every class every single time in every class loader. So imagine you have one JVM process that hosts multiple applications, or that hosts multiple layers of an application, like a web server, application server with an ER application deployed. So we have this big application, and you have different modules, and these different modules you have different jars as dependencies, and you don't want to load every single class every single time, because that's just excessive. So the usual scheme is that a class loader first consults a parent to see maybe the parent can locate this class, and then the class loader doesn't need to do anything. However, then Java EE came, and consequently all the consequent specs like GE currently, and they introduced this concept of web modules. And at that time, application servers didn't release that often, and there weren't that many of them. So you had problems if you just go and ask parent to load every class, because your application class loader will consult your containers class loader, and that will consult the bootstrap class loader or something. But it will load classes from the places that are bundled with your application server, which might be outdated, especially if the release of your application server is like once in a year, or maybe once every 2 years. If you want something more modern, you need to bundle that with your application. So it made totally sense to make that every WAR module, every web application deployed like a WAR, would have priority over the parent class loading scheme. So you can bundle a version of your libraries that you want, and then your class loader will find your classes first, instead of going to the parent and then playing some outdated version of library. And it kind of also makes sense, but lots of problem comes from this unsatisfactory ruining the core principle of hierarchy. And additionally, so you have different class loaders, and you can have different namespaces. So classes loaded in one class loader are not exactly the same as classes loaded in another one, even if they have the same name. And so this is really cool because your different applications can have different classes for common things like person or client. So those all were good intentions, but then came the real world. So the hierarchy in a typical application server environment would be something like that. So you have multiple class loaders that can be configured in any topologies that they like based on the type of the application server. So Jetty would be really different. That black box of class loaders for Jetty would be really different from that black box for WebSphere or something. And then you have multiple class loaders on the ER level, on the applications level, and every module also has a class loader in itself. But the interesting thing is that if the spec requires the WAR class loader to load the classes and try to obtain the classes first by itself to prevent this outdated library thingies, the application class loaders at the ER level is not required to do so. So if your WAR web application class loader doesn't find the class, it consults the parent, and the parent, this ER level class loader, doesn't go look for the classes first. Instead, as any normal class loader, it will call the containers one. So this is a great mashup of class loader hierarchies in Java EE, and problems will come from that. And now we'll go to problems. So this is where I start showing you some code, and we'll start discussing different situations that occur. I hope everything can work well. So I have a sample project here, and I have a Tomcat server running through my IntelliJ IDEA. So the application is very simple. It's just a servlet, and what it does, we take a util1 class and just say hello. Wait. Yeah, you can see that, so let's start. Presentation mode. Is this better? No? Toggle presentation mode. I need font. Colors and fonts. Font size. Command mouse wheel. Command. Does it work? Font. Oh, so embarrassing. Font, this one. Size. 30. No? No? Save as? Oh. 30. Okay, this is done. Well, it works somewhere. primary font, secondary font. Everything should be working, no? Apply, okay. Oh, great. So, and I will probably need to lower the window. Yeah, perfect. So we have a sample servlet here, which will respond to my GET request. And just it does instantiate a new util class and says hello. So obviously, this is a really simple method. So what we intend to see when we request this servlet is a string hello. So let's go to the browser and see that. And that is not hello at all. So what happens is that I receive a no class def found error here, and it says that class util1 is not found. Who knows what's the deal? What is wrong with this servlet? So let's go back and check this. What did they miss? This is the usual problem. Who has seen no class def found errors while developing something? Okay, easier to ask who hasn't seen them. Okay, so what do you usually do when you receive that? Yeah, that is correct. You want to see what is actually on your class path. So compiler and your IDE says one thing, that all the classes are available, but actually that might not be the case in your runtime environment when you have a different class path. So how do I check that? What classes are available? I obviously need to comment this out, and I will need to do something. I will actually go to copy a snippet because programmers should be lazy. So what we do here, we try to print, and we get a class loader for this test1 class, where we try to load this util1. Because as we've seen on the example previously, when we instantiate this util1 object, it actually goes and locates a class and asks for that class in the same class loader that this object was queried for. So we take the class loader of the test1 class, and we call the method getURLs. What is returned is a set of URLs that show me my class path. By the way, note how awesomely I just changed my code, and without waiting, I could see the results of that change in action. So what we can see that actually a single jar file resides in the class path, and only classes from that jar file and classes of this application itself would be available for me. So we have to go there and figure out what is happening. So let me just copy this path and terminal. You cannot see the top of the screen, right? And browser as well, right? Now you can. Now you can. You can see this. You can see my browser. Exceptional. You can see my terminal. Can you? I'm just checking you. Actually, I'm trying to resize the window. So no, still not. Bottom is not here. Great. So here we have this set jar file that is responsible for our class path issues and ClassNoDefError. So what I can do jar minus, what was that, tvf, something like that, no? So we can see that actually in this jar file, there is no util1 class, which means that something went wrong previously before deploying this application to the application server, but that doesn't help us anyhow to prevent those exceptions at runtime. So now I understand that class is not found because it's nowhere to be found from within this web application class loader that loaded class test1. And it consults the parent, but parent doesn't know about this util1 as well, because parent is just an application server, and obviously it shouldn't know anything about my util classes. So to solve this error, I would need to rebuild my application and properly bundle jars from my dependencies into my project. And that is probably the only errors that that are related to having not enough classes on your class path. And they come in two different flavors, but the troubleshooting techniques for both of them are actually very similar. So first of all, you want to make sure that your class is available in your compilation environment. So that will probably be like an IDE class lookup. But then you want to be sure as well that your application server or your application class path at the runtime also knows about those classes. So, and then you use getURLs method on the URL class loader. Most of them most of the instances of class loaders are URL ones. So that is almost universally available. And then you just go and see if the class is there or not. So having no classes is actually the simplest case. You know that something went wrong on the building phase. But then we have different examples as well, more interesting ones. So let's go to test 2. And this class does instantiate util2 and also says hello. And I don't like this. Let's do bonjour. And let's say bonjour. No, we won't do that. So we just obtain this class, and this util2 class also resides in the jar file. And has, as we've seen from the class path in the previous example, the util2 file actually, util2 class is actually available here. So what should happen here? If I try to access this test 2, everything should be okay, right? We should see this bonjour or hello. So, surprise. Actually, this is a surprise. So no such the no such matter error is what I expected to see here, but the method name is different, interestingly enough. We'll talk about that later as well. So the reason is that when I look at that class, this util2 class that is pre-bundled and packaged available in my application server environment, something is wrong and something is mismatched on the method level. So you can also get no such method error, or you can get abstract method error, or you can get other flavors of method-related errors. And it usually means that the class that is available at your class path in the runtime is different and was compiled from the different source that your current build project compiles against. So you have different versions. And to check if that is true or not, we will unzip this class, and then we use Java P with some key to see what exactly is available in this util2 class. So Java P takes a class and prints some information about obtained from the bytecode. And you can see that actually the only thing available to me currently from this util2 class is a constructor. So that means that actually I intentionally compiled this previous version of util2 packaged in the jar file. But it can happen in the usual development process as well. Happens fairly often. And how to do that? How to solve this? It's really easy. So we had troubleshooting the previous one, and actually troubleshooting is kind of the same. So if you encounter an instance of, as I like to call them, alien classes, basically which are classes that you want to have, but they are different. And those results in errors that look like that. So you not only get fields, but you also get errors, method and field errors, class casts, illegal accesses. All that means usually that your class is not compatible on the levels that is lower than the class itself. So either fields, methods, or something like that. And to troubleshoot that, get a resource of that class. So you will obtain the path where this class was loaded from. And when you do that, you can go and see what this class represents internally. So this get resource will show me, I will show you as well, that if I comment out this erroneous line and copy the next snippet, so we get a resource from this class loader, and we just replace dots with slashes to obtain the directory structure that we want. So, oh my God. So refreshing this, we see that this util2 class has been loaded from this jar file. And this is really useful because you don't need to actually go and manually search a class path for classes that look like that, but you can actually ask from the runtime itself, where do you load that? And then you can investigate this class. So, yeah. And then we have a couple of examples, a couple of more examples, which are using a factory, obviously. Any decent Java program should use a factory. That is a joke. So this factory 3 resides in a different project, and it returns a util3 instances. And we have 3 different methods with 3 different examples. So first one we called an instance untyped, which creates a util3 but returns an object. So this test casts this back to util3 and asks to say hello. Obviously, you know that something wrong will happen now when I access this servlet. Who knows what will happen? Yeah, exactly. We'll get a class cast exception, which is a really weird one. Util3 cannot be cast to util3. Who has seen something like that during development? Kind of less people than deal with classes not being found. So the reason why class util3 cannot be cast to class util3 is that actually at the JVM level, the identity of the class does not only consist of the fully qualified class name, but it actually consists of 3 things. So the class is identified by the class loader that loaded that, by the fully qualified class name, which includes the package and the class. Right? So that triplet should be exactly the same, and then those classes are the same. If something is not equal, then obviously classes won't be the same, and you cannot cast instances of incompatible classes. So you get this class cast exception. How can we deal with that, and what we can ask from our runtime to help us figure out what is happening, where those classes come from? So we will comment this erroneous line and see if we will see if classes actually loaded by class loaders in test 3 when you try to use that util3, and the class that was created in the factory, if those are the same or not. So I just need to save this. Let's hope this works better than the previous example. Yes. So we can see 2 URLs to classes, and we can see that one contains the first one that was loaded by my application in my servlet. And it expects this util3 class be from this jar, but actually the factory creates the jar from the util3 class. And this is an interesting topic because this brings us back to, no, it doesn't actually, it's not yet. It doesn't bring us yet back to the PDF. So you can see that those classes are loaded, reside in different jars. and those are loaded by different class loaders. Because this second one from the factory, this resides in the shared jar under the Tomcat server itself. So my application doesn't know about any shared classes that are available in the application server. But when it doesn't find the class itself, it asks from the parent. And the parent is smart. It goes into shared in the lib directory and loads this class. Because what happens is that when we ask a factory is also not available for me from the application class loader. So the factory is loaded by the shared class loader. When the factory calls and creates the util instance, it instantiates the class util3 in the same shared class loader, because the shared class loader knows nothing about my application. So, and that util3 gets back to my servlet, where I deal in the universe of my web class loader. And it also tries to convert to util3, but to convert to a class, it has to obtain the instance of that class to be able to manage that. So it loads the util3 class in the web class loader as well. And those classes are different. And then the JVM says no. So this cast will result in a class cast exception. So the bad thing is that your IDE or your build environment can do nothing with this, because it has no idea of the hierarchy of class loaders, mostly in the usual setting. And so you will have to debug this at runtime. Luckily, we have means available to us. So we just saw a single one of them. So if I check the next example, then we do not cast this factory 3 util3 to our util3 instance here. So this instance method returns an actual util3 instance instead of the object as we've seen previously. So will I get a hello from this example? So this method obviously also says hello. Or will something happen? And what will happen that is most interesting? Actually, a pretty unexpected exception will happen. So, and it's a fairly long one. So what happens here is a linkage error. And the constraint is violated that the factory 3 method, based on the same examples that we've seen before, loaded in a shared class loader, and the util instance constructed from the class that is loaded by the shared class loader, they cannot be cast explicitly to the util3 loaded in the web module. But it doesn't mean that they cannot be cast implicitly, right? So the JVM doesn't know how to do that, but it doesn't create a cast. Instead, it just, when loading classes and when trying to load classes, it sees that those classes are not compatible, and they cannot be linked together. And it throws this linkage error. And this is a good one, because it actually says what happens in which class loader and what the things that call that. So this is a fairly satisfactory error message. Actually, one of the best that JVM can offer. So still, we can go and see where from this class loader and where from those classes are loaded. So I need to comment this. We also get the class loader of test4 and uses see if test4 loads this util3 from somewhere appropriate. And yeah, we see that web module class loader has an instance and knows the instance of this util3 class. And nothing would happen if the class loader, web module class loaders would behave as any other class loaders and ask parent first. They will go to the shared class loaders, that will locate the instance of util3 from the shared directory, and everything will have worked. But no, web applications class loaders are sneaky. So this loads this util3 first and then results in that ugly exception. So the last test that we have here is an instance package. So this is a protected method, and we return an object here, and we ask that. So both classes, both test5 and factory, reside in the default package. So that's why I can have access from test5 to this instance package method. So who knows what will happen here when I say hello? Actually, I will finally get this hello, but not really. So I get this illegal access error. And this shows that actually the packages that are used to validate if you have access to protected methods and to default visibility methods, the packages are also different if they're reloaded from different class loaders. So despite my IDE saying that, oh, everything is good, they're in the same package, everything is nice, the class loaders are different, packages are different, and the JVM says that I don't have access to that. And obviously, yeah, so I can also debug this as usual, as we saw a couple of times before. So I just get a class loader of the factory3 method now, a factory3 class now, and see if I get the resource util3. So obviously, now this works as expected, and I see that this util3 class is loaded from the shared jar, unlike in the previous example. So from this mismatch of class loaders, I get all those kinds of exceptions. So when you have more classes that you need, which usually results in linkage errors, class cast exceptions, when you explicitly cast, those are probably the most often encountered out of those classes of errors. And to debug that, you just basically you have the only choice. You ask from your class loader where did it load this class for, and you ask that in different using the different classes that you use. So the caller and the class that instantiates the instance, and you compare the resources and figure out if that works or not, or if that is the same class or not. So yeah, last three examples all operated on this premise that the shared class loader is actually very different, and the web class loader goes and locates the class first. So now we have like just a couple of moments, and we will talk about class loader leaks as well. So class loaders not only are tricky to debug and to figure out what is happening when your build environment and your runtime environment are configured a bit differently, but they also can consume quite a lot of memory. So the deal is that class loader always has a strong reference to all the classes that it has loaded, and vice versa. Every class has a reference to the class loader. So, and all classes that are loaded, if they contain static fields, they also have strong reference to those static fields. So whenever you have initialized in any static field and that sits there, that it will always retain in memory as long as your class loader will retain in memory. And you can hog your permagent space or meta space in Java 8, and you can get a class loader leak, which is not that good. And actually to get that, it's not that uncommon. You don't need to do anything complex. For example, if in your application server you trigger a redeploy process, what is created, the old application gets undeployed and utilized. The new version of application gets deployed. Obviously, it gets a new instance of class loader. It instantiates objects, and then it tries to, in a good case, it tries to recreate state of the existing objects that you had, or maybe not. But still, one class that is leaked, one object, one instance of the object, any object loaded by the class. You use database in your application. You use database driver registers itself at the bootstrap because it's required to do so by spec, but then it isn't required to unregister itself on the finalized stage. So it sits there registered all the time, and you leak that one object, and that object has a reference to its class. That has a reference to class loader, which has a reference to everything that we've seen before, all classes that was loaded, all static fields. So actually, it's surprising that the redeployment don't throw those out-of-memory errors every single time. But now when you see that, you should know that probably some small object somewhere in the really either a thread or some thread local in some thread pool that is initialized by your application server, or something like database drivers are not properly utilized on the undeploy. So, to wrap it up, we actually can do better than this hierarchical tree structure of class loaders, with and the exception of web application class, web module class loaders loading classes eagerly and greedily first. So what we can do, we can have every jar file, which is a bundled, every bundled dependency has its own class loader responsible for loading classes from that single instance of that jar file. There is no hierarchy between class loaders. They are all siblings. They don't ask each other to load stuff. But then there is one central repository that manages the explicit imports and exports between those jar files. So you can declare what operations and what classes are you actually offering publicly to other jar files to use, and what exactly do you want to use. So you usually import on the Java source level. That is really like one-way road. You say, I want to use Hibernate. And Hibernate knows nothing about your classes, right? So it would be really cool if we could declare both imports and exports. And then when you ask for a class and you cannot find that class in your jar file, you go to the repository. It determines by the package name what jar file contains that, and it loads from there. So this is kind of the architecture that OSGi follows, or JBoss modules follow, or the NetBeans modules or something. There are different implementations of this scheme, OSGi probably being the most famous. So, but yeah, we're still also stuck with the usual tree hierarchy things, which is also a basis for the usual Java SE class loading scheme. But at some point we can do better. So, the takeaways from these long sessions with a couple of demo failings. So, always validate your assumptions. The thing that your IDE says that everything is perfect doesn't mean anything, because your runtime doesn't care about your IDE. Your runtime has its own perspective, and you should always validate that, and you always should go from there instead of panicking and trying to figure out why Java is so stupid. Second takeaway is that leaking class loaders are really easy. So it's not enough to isolate different components of your applications on different services. It's not enough to just load them in different class loader. Most definitely something will go wrong. So isolation works on the process level. We all know that. Everybody uses processes for isolation. Ruby's, .NET people, any virtualization people, everything. So if you really need to kind of isolate your one service to make it like reloadable or not dependent on the other stuff, so use processes better than trying to implement something really shady with class loaders. And finally, as this is a sponsored talk, Rebel is a cool tool that allows you to instantly see changes that you do to your class files. And basically, as I introduced those snippets into my IDE, it allowed me to instantly see those reflected in my runtime environment. So without Rebel, this presentation will be a little bit longer, something like 15 minutes longer. So not 15, but at least 10. So Rebel rocks. Thank you, Rebel. So now we have 6 minutes for questions. If that is not enough, we as a company, as a ZeroTurnaround, present at the ZeroTurnaround booth at the expo floor. So if we will not be ready in 6 minutes, just come find me there and ask all the questions. But we probably have some as well.
So in your examples, we tried to say hello using like a class from a different class loader, the util3 class. How can we do it eventually? Like, can we get a way to say hello from your web environment class loader?
So yeah, so the question was, we saw a number of examples, and let me go back to those examples. It's a really good question, by the way. Surprisingly, I know the answer as well. So, for example, this one, the class that tried to say hello and using the factory instance. Yeah, so the deal is the factory doesn't know anything about my application, and the factory will instantiate the util3 from the shared class path, right? So to avoid this class cast exception, I will need my web application class loader also know about that shared class path example. So if I do something like test3 get class loader get parent to get to the shared, load class, give the full class name util3, then I will obtain the instance of util3 class that it actually came from the same class loader, and then I will call this factory3 instance untapped, and those util3 will come from the same place, from the same shared class loader, and then it should work. I have 4 minutes. We will try that later when there is no more questions. But this is a weird way to handle things. Anything else? There is one.
Is there a way to have those errors detected during the development time in the IDE?
Sadly, using the usual architecture, probably not. So the reason is that your IDE operates on the class path that you declare at the compile time. So you can have dependencies that are actually provided by the environment where you will deploy your application, and you never know if those dependencies are actually the same as you think they are or not. And well, as you've seen, everyone encountered at least no classDefFound error, which means that the assumption that your build environment and your runtime environment are the same is clearly not correct. So if you follow a certain architecture and if you build build tools that will validate those things, then you kind of can resolve most of those errors at the runtime. But still, some class loader will just go to the parent unexpectedly, and well, something unexpected will happen.
Just a simple question. Can you unload a class from a class loader?
Actually, you cannot. So what you can do, you can destroy the whole class loader. So if you lose all the references to all the loaded classes and the class loader as well, and you behaved really nicely and didn't register database driver or something, then your class loader will be unloaded, and all the instances of the classes will be unloaded. But to say that you have a class loader and I want one class to retain in memory and the second class be unloaded, that is unfortunately not happening. And you cannot like reload the class as well. So say you load it once and then you say, oh, I want to add a method. That is not possible as well. Anything else? I think that is it then. Thank you.